Here's my week 3 check-in for dynamics. Total time spent studying. Spent about 2.5 hours going over the core videos for chapter 12. About an hour going over old review videos between old physics and old math. And then I spent about 3 hours on the homework so far. For the videos that I've seen, as I said, all core videos. Then I went back, went over integration by parts, did some review there, and then actually did the problems. Then would watch through, make sure everything was good. And then did a bit of physics review with centripetal forces, or the two hanging objects videos, since we had done those as part of some of the examples. So, centripetal force being the force, causing the acceleration inside the curve. For the integration by parts, I believe should be right here. UdV equals UV minus the integral of V du. And then just kind of each problem is a separate video and such. And yeah. And then homework problems I've done chapter 12, numbers 1 through 7. Focuses on gravity, the normal tangent acceleration. I can pull it up. It's number 8. But yeah, lots of focus on centripetal acceleration, or just drag or kinetic diagrams and such. So yeah, applying geometric constraints, using kind of what we did in chapter 11 with finding groups of unknowns and using them as variables and making those known until we can figure out parts later on. Lots of different problems involving tension at different points with different accelerations or just forces. Like here, tensions are different at point C versus point D, because some tension is going up and to the right, and movement is also important. That's where the kinetic diagrams are very important as well. And so kind of putting where the acceleration is happening and what they equal is important. I actually need to come back to this guy. And yeah, like I said, ellipse or planetary motion. No, that was not the sun one. Oh, yeah. Like I said, some gravitational. This equation works for anything. It's just force gravity. We got a constant, and then mass of object 1, mass of object 2, and then the distance between them. And other efforts, just did a 15-minute group meeting. We introduced ourselves, kind of went over the timeline and what we need to do. Then materials learned, the normal tangent acceleration. Not that the normal acceleration is anything crazy, but velocity squared over the radius. Kind of learning how to apply it. Again, lots of central forces, angular momentum, which O equals mvr squared, and how that is conserved. And planetary forces, shown in the homework, F equals gravitational constant times big M, little m, over r squared. So, yeah, everything we kind of went over. Everything's a little jumbled, but I said this kind of gave me a bit of trouble last week. We have the radial and transverse here. How we can kind of put it at different times and just have different forces on it depending on where it's at or what's acting on it. I still need to go over eccentricity a bit more, but it hasn't been a huge part yet. But yeah, we're working on it.